Hi, this is Beverly Ajuzzi going over the applications in data analysis course in TLT's online library. I'll be doing the introduction. The presenters for this course include me, Abdullah Mogal, Rachel Lee, and Rem Tial. Our table of contents includes Introduction to Data Analysis, Applications in Business and Nonprofits, Tools and Techniques, and Future Trends and Careers in Data. So what is data analysis? Data analysis is the process of gathering, arranging, and analyzing data in order to find relevant information, make inferences, and aid in decision-making. It assists businesses in transforming unstructured data into insightful knowledge so that they can make sound decisions. Two brief examples in the industry are marketing. They analyze social media engagement to improve ad targeting, and also healthcare, where they use patient history to predict the risk of disease. Now we're moving on to the importance of data analysis. Data analysis provides informed decision-making. Data analysis will allow companies to base their decisions on facts, not assumptions. Whether it's launching a new product, entering a new market, or adjusting pricing strategies, analyzing relevant data helps businesses make smarter, low-risk decisions. Number 2 would be understanding customer behavior. By analyzing customer data, such as purchase history, preferences, and feedback, companies can better understand their audience. This insight enables more personalized marketing, improved customer experiences, and stronger brand loyalty. And now we move on to number 3, identifying market trends. Companies can spot trends in their industry or target market by examining data over time. This helps them stay ahead of competitors, innovate, and adapt to changing consumer demands. We move on to number 4, improving operational efficiency. Data analysis highlights inefficiencies and bottlenecks within internal processes. Businesses can use this insight to reduce costs, optimize supply chains, manage resources better, and increase overall productivity. Number 5, measuring performance. Companies use data analysis to track performance metrics like sales growth, marketing ROI, employee productivity, and customer retention. This allows them to assess what's working and where improvements are needed. By identifying key performance indicators, KPIs for short, businesses can set measurable goals and evaluate progress over time. Regular analysis of these metrics help leaders make timely adjustments and stay aligned with strategic objectives. Now we're going on to 6, reducing risk and fraud. Analyzing historical data can help predict and prevent potential risks, such as financial fraud, system failures, or supply chain disruptions. This proactive approach saves money and protects company assets. Companies can build risk models that detect unusual patterns or behaviors, allowing early intervention before problems escalate. It also supports compliance with legal standards and boosts stakeholder confidence in the organization's security practices. And now we move on to the last one, driving innovation. By exploring patterns in data, companies can discover new business opportunities or products. It can also inspire innovative ways to solve problems or serve customers more effectively. Data insights often reveal unmet needs or gaps in the market, guiding research and development efforts. Additionally, innovation driven by data allows companies to stay ahead of trends and continuously improve their offerings. Now we're going over types of data analysis. The first type being descriptive analysis. Descriptive analysis focuses on what happened by summarizing historical data, such as sales reports or customer trends. Its big question is what happened. So if you think of descriptive analysis, think of what happened. An example is a company tracking last quarter's sales across regions. Our second type is going to be diagnostic analysis. Diagnostic analysis looks at why something happened by finding patterns, relationships, or causes behind a specific outcome. And its big question is going to be, why did it happen? A good example of this is going to be analyzing why a marketing campaign underperformed in one region. The next type of analysis we have is predictive analysis. Predictive analysis uses past data to forecast future outcomes, helping companies anticipate trends or customer behavior. Its big question is going to be what is likely to happen. A good example of this is going to be a business forecasting next month's revenue based on historical sales data. And last but not least, our fourth analysis is going to be prescriptive analysis. Prescriptive analysis recommends what actions to take by combining data and predictive models to guide decision making. Its big question is going to be what should be done. And a good example of this is going to be suggesting the best product pricing to maximize profit.
So now I will discuss data applications in businesses and nonprofits. So first is market research and consumer insights, and companies analyze customer data, whether it's demographics or purchasing behavior, to understand their customers' preferences and predict trends. And then another way is using data to create financial budgeting. So this includes when businesses track revenue, expenses, or profitability to allocate budgets effectively. An example of this is that a company may have to cut costs in underperforming areas while investing in more high return initiatives. So in relevant news, this might be why a lot of layoffs are happening, because businesses are able to analyze their data and see these weak areas. And then the last way is operational efficiency and process optimization. So data helps identify inefficiencies and streamline processes. And one relevant example may be a manufacturing company uses predictive analytics to reduce equipment downtime. So this allows them to just save more money, but also just not use the equipment for as much as they thought they would need. And then now I'm going to talk about data in customer behavior, market research, and financial forecasting. So first, in customer behavior, companies need to analyze their customers' interactions with a website or purchases, and this allows them to understand what drives the customer's buying decisions. The data sources of this area comes from website and analytics. So this includes things like how many clicks a customer may click on a product in their website. And then another way is surveys and feedback. And then data is used in market research because it helps businesses understand industry trends, consumer demands, and competitive landscapes. And data is collected mainly just through customer demographics in this area. And then the last part is financial forecasting, and data is used by companies that analyze their historical and real-time data to predict future financial performances and make informed budgeting decisions. So this mainly comes from sources such as sales data or revenue trends, and then also economic indicators. So this would be the inflation rate and interest rate. So now I'll dive into how data is used in nonprofit organizations. So first is fundraising. Companies can understand how much money they've collected and how to allocate it. And then next is data is used in community needs. So based on the demographic or areas that need help, businesses can probably create programs to target those areas and help those people specifically. And then another way is volunteer engagement to just overall see how much impact they've made on a specific area. So for TLT, data is used to support youth and optimize outreach. So for the youth part, data is collected to see their impact for like youth programs such as the small business entrepreneurs. And then data is also used to create the impact report, because within the impact report there will be areas such as donations, how much money was collected from each area, but also the impact of their programs such as the internship program, such as who comes from what area of Texas, and the overall hours spent into this program. So this overall just comes into program effectiveness and participation. So this gives an overview of how TLT's impact is on Texas.
Now we're going to move into one of the most important parts of data analysis, the tools and techniques that help make a sense of raw data. Let's start with data cleaning. This is the process of removing duplicates, fixing missing or incorrect values, and making sure data is in a consistent format. Without clean data, your results can be misleading, so this is a step foundational. Next, we have trend analysis. This technique help us identify patterns and changes over time. It's useful in areas like sales, marketing, and operations, basically anywhere we want to forecast and understand performance. And finally, survey analysis. This involves interpreting responses from surveys to understand opinions, satisfactions, or needs. It's commonly used in both business and nonprofit spaces to guide decisions based on real feedback. Let's take a look at some of the core methods used in data analysis, starting with the tools. Common tools include Excel and Google Sheets, which are great for organizing data and performing quick calculations. Tableau is popular for creating powerful data visualizations. And then we have Python and SQL, which are more advanced tools for handling large data sets and automating analysis. In terms of methods, the key ones we use are the same we just mentioned: data cleaning, trend analysis, and survey analysis. They help prepare, examine, and interpret the data in a meaningful way. And finally, we bring it all together with visualizations, like charts, dashboards, and reports, which help us communicate our findings clearly and effectively. Once the data is cleaned and analyzed, it's time to present it, and that's where data visualization comes in. Let's start with charts. These include bar, line, and pie charts, which are great for making visual comparisons and spotting trends. They help turn numbers into something that's easier for people to quickly understand. Next are dashboards. These are interactive visuals that bring multiple charts or metrics into one display. Dashboards are especially helpful for real-time monitoring, for example, a company's sales performance or website traffic. Lastly, we use reports. These are structured presentations of our findings that guide decision making. They often combine charts, tables, and written insights. A good report not only shows the data, but tells a story behind it. As the quote on the slide says, good visualizations make complex data easy to understand and act upon. And that's really the goal of any analysis.
All right, now we're moving on to our future trends and careers in data. What is AI and machine learning? AI refers to the simulation of human intelligence in machines that are programmed to think, learn, and perform tasks typically requiring human intelligence. This includes reasoning, problem solving, language understanding, and perception. AI can be classified into two types: narrow AI, which is designed to perform specific tasks such as facial recognition or voice assistance, and general AI, which is more advanced and aims to perform any intellectual task that a human can. Common examples of AI in everyday life include virtual assistants like Siri or Alexa, recommendation systems on Netflix or Amazon, and self-driving cars where machines learn from vast amounts of data and adjust its actions accordingly. On the other hand, machine learning is a subset of AI that involves the use of algorithms to allow computers to learn from data and improve over time without being explicitly programmed. Machine learning systems are trained on large databases and can identify patterns, make predictions, and make decisions based on new, unseen data. For instance, in email services, machine learning algorithms help in filtering spam by learning from various email characteristics. In healthcare, machine learning models can analyze medical images to help diagnosing diseases like cancer. Machine learning is also widely used in areas such as finance, marketing, and robotics. The continual learning and refinement process is what makes machine learning particularly powerful in dynamic and complex environments. So how do they impact data analysis? AI and machine learning automate the process of extracting insights from large datasets, reducing the need for manual analysis. Algorithms can quickly identify patterns, trends, and anomalies in data, providing businesses with real-time insights to inform decision-making. AI and machine learning improve predictive analytics by analyzing past data to predict future outcomes more accurately. These models can identify hidden patterns in data, enabling better forecasts such as predicting customer demand or financial market trends. AI and machine learning enable more personalized decision-making by analyzing individual data and tailoring recommendations. For example, in e-commerce, AI-driven recommendation systems suggest products based on the user's past behavior. And now we're moving on to real-time data processing and big data. Real-time data processing involves analyzing and acting on data instantly as it's generated. It's critical for immediate response in sectors like security, smart cities, trading, and patient care. The technology includes Apache Kafka, Apache Spark, and Google Cloud Dataflow. Now, big data refers to data sets too large or complex for traditional processing methods. It's used to uncover patterns and trends in sectors like business, healthcare, and logistics. The tools used to process big data are Hadoop, NoSQL, Tableau, and Azure. And now we're moving on to career paths in data. The three most common and popular career paths in data include becoming a data analyst, a business analyst, or a data scientist. Data analysts focus on gathering, digesting, and evaluating information to help guide business choices. The skills they use are Excel, SQL, Tableau, and data visualization. Business analysts focus on analyzing data, comprehending company procedures, and proposing enhancements. Their skill set includes processing mapping, Excel, and stakeholder communication. Data scientists focus on using machine learning, building models, and doing sophisticated statistical analysis. Their skill set includes knowing Python, R, SQL, machine learning algorithms, and deep learning. Some key skills to learn would be programming languages such as Python, R, or SQL, some type of data visualization tool like Tableau or Power BI, machine learning and AI concepts, and some data engineering using big data tools and real-time processing. Some soft skills to learn would be problem solving and critical thinking, communication and storytelling with data, and business acumen and an understanding of industry trends. Some emerging technologies to watch would be natural language processing for better data interpretation, edging computing, which is processing data closer to the source for faster real-time analysis, and quantum computing, which has the potential to revolutionize data processing compatibilities. This is going to conclude our applications and data analysis training video. Thank you so much for watching. Make sure to complete the quiz at the end of the video.